Okay guys, I'm going to attempt to do a laboratory for you. So you should have this handout downloaded and ready to have some pictures and some data and some explanation on this. What we're doing in this lab is we're going to be calculating the density of a gas, and particularly we're going to be doing it with carbon dioxide. So what we're doing is we're going to be going back to Alka-Seltzer again. I'm going to tip this over here so you can see our things that we're going to be using. We're making a flask, a couple Alka-Seltzers, a full flask, and then we also have a graduated cylinder that is filled with some water. So let me explain what we're doing. Again, we're looking at density. So in order to calculate a density, we need a mass and we have to have a volume as well. The first part of the lab is we're going to be calculating the mass, and the second part is we're going to be calculating the volume. So let's take a look at this first part. What I'm going to be doing is I'm going to be taking this flask, and I'm going to be taking this Alka-Seltzer, and I'm going to weigh it on the scale before dropping it in. And of course, after I drop the tablet in, the mass is going to decrease, because what's going to happen is as it dissolves, the carbon dioxide gas is then going to be escaping out the mouth of this flask. Let's go ahead and write that first part right here. So we have our flask, our first flask. It's going to look like this, and you can go ahead and draw this like this, and we have the little Alka-Seltzer sitting at the bottom. We're going to fill it with water, and of course an Alka-Seltzer bubbles, and all those bubbles are going to be leaving as carbon dioxide gas, CO2. So as the CO2 leaves, the mass of everything is going to decrease. So we're going to have this lost mass. If you remember from the last chapter, this is an open system. It's not a closed system. So this lost mass is actually going to be equal to the mass of the carbon dioxide. So as it dissolves, the other chemicals are going to remain down here, and only the carbon dioxide is going to be leaving. So the difference in mass is going to be equal to the mass of the carbon dioxide. So that's what we're going to be doing with this first part of the lab, with those two things. So I'm going to go ahead and do this, and that way we can go ahead and go to the second part of the lab as well. So if you'll follow me, I'm going to take this over to the scale here, and what we're going to do is we're going to zero that scale. I'm going to put that on there, and we're also going to put the Alka-Seltzer tablet on there as well. Let's go ahead and record that, 165.51. So it's going to be 165.51, and that's going to be in grams. Okay, 165.51. What I'm going to do is I'm going to go ahead and drop this tablet in. Go ahead and drop it in at an angle. Okay, and of course, it's going to dissolve, and it's going to be bubbling. Okay, and we can actually see what's happening to the mass. The mass is going to be decreasing as the carbon dioxide is reaching the surface of the liquid and then bubbling out into the room. So we're going to let that go for a few minutes. Meanwhile, we're going to go to the second part of the lab. And the second part of the lab, I'm concerned with the volume. I want to calculate the volume of this gas. Well, what I've done is I've filled a different flask. Here's the flask that I have filled. Here's the flask. It's completely full with water. There's another Alka-Seltzer tablet, and then there's a rubber stopper as well. I'm going to drop the Alka-Seltzer in the water and then cover it with a rubber stopper. However, if I just left it like that, all of the gas would still bubble up into the room. I want to collect the gas, so what I'm going to do is I'm going to tip the flask upside down inside the water. So if you can draw this, and I have a little water trough right there in the sink as well that I'm going to put that in. So if you can draw your water trough, Here's the water trough like this. Okay, and what I'm going to do is I'm going to have this flask is going to be upside down, okay, in the water. It's going to have, okay, a little hole in the rubber stopper like this. So that means the gas will be collected because the gas is going to be bubbling upward. So as the gas bubbles upward, it's going to be collecting up here, and it's going to be actually pushing the water out. So at the top of here, this is going to be carbon dioxide. Those bubbles will be collected, and then the water is going to be pushed out as the bubbles are going to be collected. Then what I can do is then I can take this flask and turn it right side up. So I'm going to take this, and then now we're going to put it right side up so it's sitting on the countertop. And I'm going to pull out the rubber stopper. And of course, what's going to happen is there's going to be some water that was pushed out. So what I'm going to do is I'm going to take a graduated cylinder. This graduated cylinder is filled with 100 milliliters of water. And then I'm going to pour some water into the flask until it fills it back up again. So before getting to the summary, you can see where this is going. So the bubbles from the Alka-Seltzer, which is the carbon dioxide, collects in the flask. The water gets pushed out. As I turn this right side up again, okay, the gas can't escape, and that's going to be fine at that point in time because we're concerned with the amount of water that was pushed out. The amount of water that was pushed out is equal to the volume of the gas that the carbon dioxide was produced in this experiment. So the water pushed out is equal to the volume of the carbon dioxide. So what we're going to do is we're going to fill this water back in, and that water that we fill in is going to be equal to the water that's pushed out, and that's going to give us our volume. Okay, we're going to go over, we're going to see what our mass is over here. Looks like there's still a few bubbles there. We'll see if our mass is changing. We got 165.12. We'll go ahead and record that, 165.12. Okay, it's now 11, so we might have to monitor that a little bit later. Let's go ahead and get to the second part of our experiment. Okay, so here is the flask that's filled. Here is the Alka-Seltzer. I'm going to drop it and then invert it upside down in the tank. Okay, you can see bubbles are being produced, and I'm going to put that inside the water trough. Let me show you what's happening. So you can see the carbon dioxide bubbles. Okay, again, the tablet's now floating on the surface, and it's producing a volume of gas. I gotta clean this mess up. Okay, feel free to fast forward to the section where we're starting the data collection, because I don't want to stop this. It looks like it's pretty much done, actually. It didn't take very long. So what I'm going to do is, now I turn it right side up like this. And now what I'm going to do is I'm going to fill with the graduated cylinder. So once again, the bubbles that were produced by the Alka-Seltzer was the carbon dioxide gas. And it pushed all of this water out. The water that was pushed out is equal to the volume of the carbon dioxide. So now I have this graduated cylinder that's filled up to 100, and we're going to fill this back in. So on your data sheet, it says the volume of the water before pouring, that's going to be 100 milliliters. That's what we're starting at. Okay, I'm going to go ahead and pour this in. Okay. And it's filled to the very brim. So I'm going to take that, and now I'm going to read the volume of the graduated cylinder, and it is 41 milliliters. Okay, I'm going to wipe this down, bring this back. So it's 41 milliliters. That's the final volume. Well, I'm going to subtract that. This is going to be 59 milliliters. This is the volume of water that was added. This is the volume of the carbon dioxide that was produced. So let's try to get the density of our carbon dioxide. We obtain the mass from the initial and starting of the dissolving of the tablet, and the carbon dioxide mass escaped. The mass actually has changed slightly, so I want to take a look at that. It's 165.08, so we're going to go ahead and record that, just to be precise. 165.08 grams. The difference of that is going to be 0.43 grams. That's our mass. So our mass is 0.43 grams divided by 59 milliliters. And from this, we should be able to get the density. Getting your calculator, I'll get my calculator. We have 0.43 divided by 59. This gives us 0.00728. We're just going to round to two significant digits, so it's going to be 0.73. Okay. The actual mass of carbon dioxide, here's the actual, is 0.002. What are my units? Grams per milliliter. This is grams per milliliter. So we got kind of close to getting the actual mass of carbon dioxide. And we did that with the Alka-Seltzer with the mass that was escaping, and we also calculated the volume of gas that was produced.